Alright, oh, it's live. It's live. Alright, hey guys, what's up, people? Welcome to the session. Welcome. Hi, say hi to Shilpi ma'am. And
Hey guys! Hi,
Hello.
hi.
in
Hello
the meantime,
everybody.
yes. So, what's up, people?
Anupsar
Yes,
is trying something different.
I know. I'm playing around with this thing right now. All right. Okay, people. So what's up, guys? I hope all of you guys are doing good and your preparations are going well. So we are back with the doubt session. So all this while we were doing the marathon, now we're back with the for the doubt solving. So whatever doubts you have, this is the time for you to get it cleared with all of us. The whole science gang is here. Shilpi ma'am, Pritesh sir, and myself will be solving all of your doubts, whatever you've got. We have few doubts we had actually gotten while we had sent out the Google form. So we'll solve that. But in the meantime, if you have any doubts, put it down in the comment section or in the chat box, in the live chat, and we'll try to get that solved as well. All right. So yes, anything that you would like to add, Shilpi ma'am or Pritesh sir, please.
No, I think let us just start with the doubts because
let's
I'm
save
going
that
by
time.
the
Okay.
hour, and I think it's 18 hours left for the exam.
I know, 18 hours. All right, so I'll share the screen with all of you guys. Just give me a second. I'll just share my entire screen. Okay. All right. Yes. So people will start off with chemistry doubts. Whatever doubts you guys had sent, you or your friends would have sent these doubts. So we can get that solved first. Then we'll move on to biology, and lastly we'll do physics. All right. So here, I believe this was the first doubt that was sent. Chemistry doubts with Sriti ma'am. So here's the first question. Yes, Shubhi ma'am.
Draw the electron of structure of methanol. So guys, what you have to do here, I've given you a trick. Whenever they ask you the question to draw the electron of structure, start with the open chain structure first. So what you will do, first of all, connect the carbon with the functional group. Carbon connect karoge oxygen and single bond to hydrogen. So can you go to the next screen?
Yes, one sec, ma'am. Yes.
Yeah, thank you. So yeah, what do you have to do? First of all, draw the bond line structure. Draw the open chain structure, then remove that bond line and show the valence electrons there. Like in the alcohols, oxygen is sharing one electron with the hydrogen and one with the carbon. And where carbon is using 4 electrons, 3 with each hydrogen. And this way you can just show that. I guess easy here, not difficult. You all can do this? Yes. Okay, very good. So the hint is the same. Draw open chain structure first, then replace the bond line and show the electrons. Okay? Fine, kar lena isko, easy.
All
Very good.
right.
So we can go.
Next question.
Yeah, this is super easy. Sri Hari has asked the question. How to write the symbol of Eka silicon and Eka aluminium? Beta, so you know that Mendeleev, he introduced some of the symbols, like they were not even discovered. So Mendeleev ne kya kiya? He predicted the properties of elements which were even not discovered at that time. So it was like Mendeleev was actually an astrologer, some scientist. So you know, Eka silicon was later on named as what? Germanium. A simple trick, both of them are metalloids. So आपको याद आ जाएगा Eka silicon से germanium, And Eka gallium is the name that was given to the Eka aluminium. One more was there, Eka boron, that is now known as scandium. So remember all these 3 elements. Okay, they can ask you in the question. Simple, right?
That's it. All right. Next question again by Sri Hari.
Okay. Yeah, chemistry. Sri Hari ने full पैसा वसूल कर दिया. Okay, that is easy. Why covalent compounds are poor conductor of electricity? You know that because they are formed by sharing of the valence electrons. There are no charged species involved, so there are no electrostatic force of attraction. Simple forces among the neutral molecules, they have to be like absence of free charged particles. So bad conductor of electricity. Okay? Simple. So you can check the answer, you will get it here.
Yeah, you'll be getting the notes, guys. The notes you can download it later. Alright, the PDF would be available, so you can download it later. Don't worry about that. Yes, ma'am. Sorry.
So fourth question is, in the modern periodic table, a zigzag line separates metal from non-metals. ये तो Anup and Pritesh sir can also tell this. What are those zigzag line wale elements?
I think they are metalloids.
Yes, sir. Right. And Anup sir will give the example of metalloid now.
You just told that, no? Gallium or whatever. Gallium.
सिलिकॉन, हाँ ठीक है, वो भी दे सकते हो, हाँ ऊपर आप यू कैन गिव एनीथिंग, है ना, वो सिलिकॉन, जर्मेनियम, सर जर्मेनियम था।
Oh, germanium. Oh, sorry. My bad, people. I'm hopeless in chemistry.
Okay, so we can go with the next question.
Yes.
Vaibhav, I guess it's clear. Right. So how graphite is able to carry electricity? Very nice question. Vinod, I would appreciate you that you've asked this question. So guys, everyone pay attention what Vinod is saying. This question will not come in exam, but you know the level to where he is thinking, that is appreciable. So Vinod is saying कि graphite में क्या होता है? Every carbon is bonded to 3 other carbon atoms by a covalent bond, है ना? That means every carbon has 1 free electron with it. And we say that is why graphite conducts electricity. But the point is that one electron is also used to make a double bond. Adjacent carbon atoms use their free electron and make a double bond. So that free electron is kind of used now. So this is what Vinod is saying, that if that electron is used, then how it is conducting electricity. So the point is that those double bonds are delocalized in nature. Okay? They are not fixed between the 2 carbon atoms. वो delocalized होते हैं. They keep on shifting from 2 carbon atoms to next to next to next to and so on. So they are delocalized. That is why they can still conduct electricity. Okay, that is the reason, Vinod. Don't worry, exam में नहीं आएगा ये question. हाँ, they have also shown it here. Okay. Right. चलिए. The next question: why first 3 members of alkane family do not have isomers? Because beta, there is no other way that you can arrange the 3 carbon atoms in a different structure. आप try करो. There is only possibility you connect 3 carbon atoms in a straight chain. है ना? You can't make branches. You can't make a cyclic structure. So for the isomers, the minimum that we need are the 4 carbon atoms. Okay? Yes. Very good. Difference between valency and valence electrons, Mukund is saying, बहुत easy है बेटा. Sir, Uday is saying, is it doubt session or chemistry doubt session?
Ma'am, take it. We'll rename it. We'll rename the video itself. Don't worry.
Okay, so guys, the flow is like after chemistry, Pritesh sir will come. So we are only targeting to save your time. है ना? ये time बहुत precious है. Please do not waste it and don't attend the long sessions now. है ना? You have to take rest also, revision भी करना है. तो इसीलिए जल्दी wrap up करेंगे. ठीक है? बहुत बढ़िया. Very good. Anup sir will like, ma'am, what are you saying in Hindi?
Exactly.
So valence electrons क्या है? Valence electrons are number of electrons present in the outermost shell of an atom. है ना? And valency is the combining capacity of an element. Like how many electrons atom needs to lose, gain or share so that it can get a complete octet. Like example लेते हैं. We have calcium with us. Okay, या फिर you take the carbon as an example. कोई भी example ले लो. So you are having calcium. If you write the configuration 2882, it has 2 valence electrons. है ना? That is the valence electron. You have only counted the number of electrons in the last shell. Now coming to the valency, what is that? How many electrons calcium needs to lose so that it gets an octet? That is 2. So you see the difference? Okay, answer is attached here. You can download the notes and see that. Okay, very good. Okay, general names, Ami beta, all that we've covered in the syllabus, that is octet. Okay, you don't, any random compound won't be asked in the exam कि कुछ भी पूछ लेंगे वो, है ना? Okay, very good.
If they ask, blame Shilpi ma'am. That's all. She's sitting in a cricket stadium and chilling. Blame her. That's all.
Shilpi ma'am, yeah. You can see VSPL is going on, so I booked the ticket for that. इसीलिए I am cricket stadium.
Next one is Vinod.
Yeah. Vinod is saying, Vinod ने भी पूरा पैसा वसूल किया. Big doubt here. We like चलो लूट लेते हैं. So you see this question. 2 elements X and Y belong to group number 1, alkali metals, group 2, alkaline earth metals. Answer the following question. Part 1. Mention the number of valence electrons in their atoms and the valency. बहुत easy है. Group number 1 elements have 1 valence electron. The valency is also 1. है ना? Group number 2 elements have 2 valence electrons and 2 valency. Simple. Okay? Very good. So can we have the next part?
Yes, sorry.
Compare the metallic character and the sizes. So metallic character you can compare x to y. We are moving left to right across the period, and on moving left to right across the period, what happens? Effective nuclear charge will increase. जिसकी वजह से it will become difficult to remove the electron, है ना, from the outermost shell. So X would be more metallic. Y के केस में effective nuclear charge is higher, so it is less metallic, है ना. And because of effective nuclear charge only, because of effective nuclear charge only, you can see Y will be छोटू हो जाएगा, because nucleus will attract the valence electrons more tightly. Okay, so you can see size of Y will be smaller. Formula of oxides and chlorides लिख लेना from the valency simply. Okay, X का valency would be 1, oxide is 2. Exchange करना, you will get the answer X2O, है ना. And the same for chlorides and oxides. कर सकते हो, not difficult. Okay. Yes, Mohammed Vida, structure won't be asked. ठीक है? Yes, athletic, you can write your doubt in the chat. So that is all for chemistry, I guess. We can go to biology.
That's it. My God. Express train. Alright, so guys, I hope that all of your chemistry doubts are clear. If there's anything else left, don't leave Shilpi ma'am. She has a session at 5. Until then, you can squeeze whatever you can.
I'm still here for a few minutes.
Alright, so in the meantime, biology, any doubts that you have, guys, please put it out. Pritesh sir will be solving it. After that, we'll go to the chemistry. After that, we'll go to the... Oh, is it? I had given the access to you, ma'am, so that you could change the slides, and now you're closing it. Okay, one sec, guys. One sec. I'll share my screen again. Give me a second. I'll just, yes. Guys, if you have any doubts, in biology, you can ask Pritesh sir right now. And after that, we'll move on to physics. All right. Any doubts that you have, please type it out and Pritesh sir will solve it. All right. So you have one doubt. Could you please explain the laws of dominance, segregation, and independent assortment? Thanks in advance as well.
Okay. So, yeah, just a minute, guys. Just a minute. Okay. Am I audible?
Yeah, clearly.
So, guys, law of dominance tells us that one gene that is expressed, that is dominant, and the one that is not expressed, it's recessive. And this is a short question in the exam, that law of dominance, the law of dominance, segregation, and independent assortment, it is going to come in the exam without a doubt. So please make sure that you literally memorize the 3 statements of all the 3 laws, that is dominance, segregation, and independent assortment.
Any other biology doubts, guys? And ma'am, you also have a doubt. Does pentane is an isomer of cyclopentane?
Yeah.
Because they have, okay. Yes. Uday?
Pentene
Oh,
होगा.
pentene.
Pentene will be an isomer of cyclopentane beta. So cycloalkanes and alkenes, they have the same general molecular formula, CnH2n. So yeah, they are structural isomers of each other. ठीक है, आप बना सकते हो exam में. Fine.
Done. And Pritesh sir, another doubt for you. In any population, no 2 individuals are absolutely similar. Why is that so?
That is because of the sexual reproduction. The variations are, because of the variation, the DNA copies do not become similar, and that is why the 2 individuals are not the same.
Right.
And also, there are a lot of doubts regarding the genotype of dihybrid ratio. So guys, genotype of dihybrid ratio is very, very complex, and that is not going to be asked. It is asked like in 11th and 12th standard, not even in 11th, 12th standard mein wo puchte hain. It is very complex, and it is, if you want to know, even like I have opened it because it's too complex. It is 1:2:2:4:1:1:2:1. So it is not going to be asked in the exam. Please relax. Genotype of dihybrid cross is not going to be asked. Maximum they can ask you phenotype, which is 9:3:3:1. So please don't, waste your time trying to memorize the genotype of dihybrid cross. It is not going to be asked in the exam.
One more doubt, ma'am. For you, it's for you. How to calculate the number of isomers for a hydrocarbon? Ma'am, you're on mute. You're on mute.
Haslo koi nahi. Yeah, so I guess Yashwant has asked, Dashwant is asking, Beta, there is no general formula for that. And agar hota to kitna aasan hota. So you have to see what kind of hydrocarbon that is. Jaise alkanes mein you can use 2 raised to power n minus 4 plus 1. That is the general formula. N is number of carbon, but that is not going to help you. So please general formula ke piche mat bhago. If isomer comes, simply start with the chain isomer. Okay, so carbon skeleton dekho, arrange all in a straight chain, then reduce one carbon from the straight chain, add it as a substituent. So keep on trying these different permutation and combination. Formula is not going to give you marks in the exam. Aapko banana padega. Yeah, this thing can help you. Only chain or position isomerism would be there, and alkanes mein to only chain isomerism you will see. You have to see the arrangement of the carbon skeleton, है ना? उसको change करके देखना है. That should be different. And alkenes and alkynes mein you can change the position of the double bonds. You can change the length of the carbon skeleton. You can do like that.
This is why I don't like chemistry, ma'am. You get it, no? So many exceptions, God. So many exceptions. No use of learning the formula also. Get that, people. That's what. Alright. Okay, next question.
So just one thing I would like to add on here.
Yeah.
Like right now, I can see a lot of students are asking questions which are not in their syllabus.
Oh.
So guys, this is what you have to control. एक दिन पहले exam के your mind distract you to focus on things that you don't know, that you haven't done. This is how the mind is going to, work. आपको याद दिलाएगा, अरे you don't know this, you don't know that, you haven't done it. जबकि that is not even a part of your syllabus. So this is very important that right now you guys stick by the syllabus. Okay, strictly follow that. Right, so exam में जाके, let's say you are going for the exam 9:30 पे, your friend calls you and say what is the action of soap, or how to give IUPAC nomenclature to this. You don't have to get stressed because that's not in your syllabus, है ना? So stick by the syllabus. That is it. वरना जो आता है वो भी भूल जाओगे. That is for sure. So trust your preparation. Okay.
Another one, man. Why doesn't carbon exist in C2
Yeah,
form
so
like O2?
if you make the C2 form adput, the octet is not completed. Now oxygen has 6 valence electrons. Double bond bana ke it gets stabilized. Carbon has 4 valence electrons. C2 banega bhi to what is the fayda, है ना? So there is no advantage of that. Octet is still not completed.
Right. Write the molecular formula of lower and higher homologous of an alkene which contains 4 carbons.
Yeah, so alkenes ke liye you can simply give that n value 4. You can put in the general formula. Okay, Mohammed? Ma'am, are iso and neo isomers enough? That depends, beta, what is given in the question. है ना? क्या पूछा है? So you don't have to take tension. Okay, athletic beta, bromine is out of the first 20 elements, so you don't have to take tension of writing the configuration. You know? Yeah, placement of hydrogen in periodic table is still not fixed. You know that is a limitation of modern periodic table. You know, hydrogen resembles group 1 and 17 both. C4 is not formed beta because of the orbitals का orientation and energy भी favor नहीं करता है to make that, right? Okay. Functional groups we have done in today's session, marathon में भी किया है, so go and revise that अगर कोई भी tension है, ठीक है? Okay. That is it, sir, I guess, for chemistry.
Ma'am. Thank you so much. Thank you, guys. Please thank Shilpi Ma'amda because she has, out of all, from morning, I guess you're sitting, right, ma'am? In front of the computer from morning, marathon, and then now again, regular sessions. So, can we have a big round of applause for Shilpi Ma'am and Pritesh sir as well for doing an amazing job. Thank you everyone. Okay, so I think we'll go to the physics doubts now. If there's anything else left, please let us know. We'll try to clear it. But in the meantime, for all those who are asking for physics doubts, I'll just clear some of the physics doubts as well. In the meantime, Pritesh sir, if you have any doubts that you have, you can please stop me and then you can carry forward.
No, all that I want to say is, because even I've got another class, that all the best, guys. I think we all three are sure that you're going to do really great. And just don't create any kind of self-doubt. You're going to do great. Just focus on paper presentation. And one more thing I would like to tell you on behalf of all the three teachers: just because you know something about a concept or about an answer, don't go on writing extra. Write only what is asked. This we have already discussed in my sessions. Don't try to impress the examiner with additional knowledge. Give the examiner what he has asked for. And if you serve the examiner a well presented paper with only what is asked, properly underlined, properly ruled, neat and clean paper without much of scribbling, sure, I can guarantee you that you're going to do really great. Already I've spoken in the morning when we did the marathon, that how are you supposed to present your diagrams. So follow that tips and tricks. Be neat and clean. I'm again and again emphasizing on that, because I'm sure that you know the concepts, you know your answers. Just present them very, very nicely. All the very best, guys. Make yourself, your family and us super proud. God bless you. Do great.
Well said. Thank you so much, sir. Thank you so much.
Thank you.
All right. So I think, you guys are going to leave now, right? Bye-bye. With a heavy heart.
Thank you so much, sir. All the best, guys. Take care. Thank you.
Bye-bye. Bye,
sir.
Bye-bye. Thank you so much. So alright guys, so I'll be here for some time to clear your doubts in physics. So whatever doubts you have right now, you can let me know. I'll try to clear to the best of my abilities. Alright, so the few doubts that came out very, a lot of you guys had asked was this: what is the difference between resistance and resistivity? Let me start with that. See guys, resistance is nothing but the obstruction offered to the flow of current. You guys already know that. The formula to calculate resistance is nothing but resistance is equal to rho into L by A, where rho is the resistivity, L is the length, and A is the area of cross section. So basically resistance is directly proportional to the resistivity. Resistance is directly proportional to the length of the conductor, and it's inversely proportional to the area of cross section. But what you need to understand is this, people: resistivity is nothing but the resistance of the material of unit length and unit cross section. So in other words, resistivity is the property of the material. The property of the material. When you talk about resistivity, we are not bothered about the length or the area of cross section, nothing of that sort. All we are bothered about is the material itself. What type of material are you going to use? Are you going to be using iron to make to form an entire circuit of a house, or are you going to use copper? Obviously, you choose copper. Why? Because the resistivity of copper is less, which means it is a better conductor compared to iron. So that is what you need to understand. So resistance and resistivity, the basic difference is this: resistivity is the property of the material, which basically states that it is nothing but the resistance offered by a conductor of unit length and unit area of unit cross section. That means 1 centimeter length or 1 meter length, 1 centimeter square area or 1 meter square area. That what is the resistance offered within that? That is what is called as resistivity. Now talking about the units, resistance SI unit is nothing but ohm. Resistivity on the other hand is ohm meter. This is the difference between resistance and resistivity. All right. Okay. Yeah. This is another question, sir. Why in bulb, low wattage bulb, glows better than in parallel? The answer is that in series connection, the resistance is very, very high. Since the resistance is high, the voltage across the resistors would also be, it'll differ. So what happens in series connection is that the voltage across these resistors would be, would differ or would get divided. If you have connected a 6-volt battery to two resistors which are connected in series, the voltage also gets divided across the two resistors. The voltage gets divided. Because of that, the current flowing through them is less. The current flowing through the second resistor is automatically less in comparison, because there's a voltage drop. Because of that, you can say that even because of the lower voltage, you would be able to see that the lower wattage bulb, which does not require so much of current, that will be able to work easily. But in parallel connection, on the other hand, the voltage gets voltage is same. So over there, it really doesn't matter much, in the sense, even if one device is is much more has a lot of power consumption compared to the other, it will still continue to work. For example, in your home, you can turn on your refrigerator and the light inside your kitchen at the same time, and it won't affect the brightness of the bulb. Why? Because over there, it is the same potential difference across the two resistors, and hence current flowing through them would not matter. Current gets divided, but it will be comparatively higher compared to a series connection. That is why in series connection, the lower voltage bulb can easily work, because naturally the voltage itself is less. So even under that lower voltage, the bulbs which are like these 0 watt bulbs, technically speaking, 0 watt bulbs does not exist. 0 watt is not possible at all, but they have lesser power consumption, and so they'll be easily be able to work. All right. So why is voltmeter connected in parallel? The answer is very simple now, because a voltmeter, has comparatively higher resistance. First of all, the device itself has higher resistance. Secondly, when you talk about voltage, you're talking about, for example, our resistor, let's say, all right. When you talk about voltage, you're measuring the voltage across 2 points. You're taking these 2 points and measuring the voltage. It's unlike current, when you talk about potential difference is equal in parallel connection, not in series connection. So since you're taking 2 different points, you want to measure what is the potential difference across these 2 points, and since in parallel connection the voltage would remain the same, that is why we connect the voltmeter in parallel. I hope it makes sense, people. That is the reason for it. All right. So I hope it's clear, Nishant. I hope it is clear now. Anything else, people? So I'll just go on, sir. When to convert time into seconds and when to keep it in hours? Krishna, it's very simple. If they have asked you to find out the cost, for example, let's say they have asked you to find out the cost. Now, when you talk about cost, they will give you in terms of unit. For example, 1 unit is equal to 3 rupees. They'll give you like that. Now, 1 unit is equal to what? 1 kilowatt hour. All right. 1 kilowatt hour. In that case, keep time in terms of hours, because it's kilowatt hour. All right. But on the other hand, if they have asked you to find out the energy in terms of joules, then you need to convert into seconds. Got it? If they've asked you to find out the cost, or they've asked you to find out the energy in terms of kilowatt hour, the electrical energy consumed and all of that, then you have to keep it as hours, or if it is not given in hours, convert it to hours. But on the other hand, if they've given you and asked you to find out the energy consumed in terms of joules, then you must go with seconds. So convert that to seconds at that time. All right. Any other doubts, guys? So if we move the coil and permanent magnet both, then will there be deflection in the galvanometer? Kavya, it's all relative motion. Relative motion in the sense, for example, right now I am in the state of rest with respect to the wall. The wall is also in the state of rest with respect to me. But if an astronaut is watching this whole thing, this whole scenario, or he's watching me from space, for him, I'm in the state of motion. Why? Because the earth is rotating. So relative means with respect to something, how is it moving? Now, if I talk about a coil and a magnet, if both of them are moving with the same speed in the same direction, then there'll be no deflection. If both of them are moving, because when they're both moving, basically what it means, according to, they're both moving at the same speed. So for this, this is also in the state of rest. For this, it's like, another example is the train wala example. You and your friend are in a train. For your friend who's standing outside and watching you guys, or watching the train, both of you are in motion. But for you, your friend is in the state of rest. For your friend, you're in the state of rest. So it's relative in nature. So if they're both moving in the same direction and at the same speed, then there'll be no deflection. There'll be no current induced, because the relative motion there's no relative motion at all. All right. In the sense, the relative motion here you can say is 0. All right. Okay. What unit? Again, in the case of heat, you have to convert it into joules, right? You have to find it in terms of joules. So convert it to seconds. All right. Sir, why we didn't connect ammeter in parallel compared to voltmeter? Again, the ammeter measures the current, and in series connection, current remains same. In parallel connection, the voltage remains same. You need to find out the voltage, so you would connect them in parallel, because in parallel connection, voltage remains same. And secondly, voltmeter itself has a higher resistance. So in parallel connection, it won't matter much, because the resistivity, the overall equivalent resistance will anyways be less. But ammeter, on the other hand, is connected in series, because you need to measure the current, and current is same in series connection. And in general, ammeter itself is a device which has less resistance. All right. Anmolji, go through the previous year question papers at least. Go through, if you have not started yet also of physics, I would just say this, go through the previous year question papers. We have done a lot of questions on the channel also. Take 1 hour, 2 hour time. We've done so many questions. Go through some of those questions, download the notes, download the PDF, go through the, I would say go through the sample papers also once. So try to solve the sample papers, previous year question papers. Some of the concepts that you didn't understand, watch the video of that, read the textbook, and you're good to go. All right, don't worry about that. Okay, lots of doubts coming in. So guys, I'll clear your doubts, but in the meantime, let me just clear the doubts that was put up by your friends itself. I'll clear this in the meantime. I'll take one of this, I'll take one of that, and we'll go parallelly like that. All right. So here's one. Supriya Sahu had asked this question. So give some tips and tricks to identify the poles of a solenoid. See guys, there are two ways that you can find the poles of a solenoid. One is basically the clock face rule. So according to the clock face rule, what it says is that the side that you are facing, if current is going in anti-clockwise direction, then that, if it is going in anti-clockwise direction, then that would be the north pole. If the side that you are facing, the current is flowing in clockwise direction, if it's going in clockwise direction, then that would be the south pole. Just remember this. This is one way to find out. Another way to find out is by using a magnetic needle also. You can use a magnetic needle. The compass, the directional compass can also be used to find out the direction. So what you do here is you take the compass and bring it near the solenoid, all right, near the poles. Now, if the needle starts to deflect, let's say that this is the north pole, all right, let's say this is the north pole of the compass. When you bring it near the solenoid, let's say this is the solenoid and you bring it near it, if the deflection is going in the opposite direction, that means this is the north pole. Why? Because north and north pole will repel. Simple common sense. On the other hand, if you take the same compass and bring it to the other side, let's say this is the south pole of this solenoid, if you bring it closer, the needle of the compass will point towards it. Why? Because this is the south pole, and unlike poles always attract. So these are the two ways that you can use to find out the direction or the polarity of a solenoid. Alright, so one is using the direction of current and the other is by using a simple magnet. So any of these things can be used to find it out. Second question, before that, any other doubts that I've missed out? So three resistors A, B and C are connected as A is in series and B and C are parallel in same series. Each of them dissipates energy and can withstand maximum power of 18 watt without melting. Find the current through ABC. This kind of question would not be asked as much, but you can calculate it, but you have to assume a lot. There's a lot of assumption that goes in it, but I'm pretty sure these kind of questions will not be asked. Okay, this is a little too much because for your level, for your 10th standard level, from what you have studied, it's a little too much. So you can expect it to be not this difficult and all, right? Because there are a lot of unknown values over there. All they've given is the power and they've asked you to find out what is the current. So these kind of questions will not be generally asked. For a general rule of thumb is that this type of questions will not be asked. So don't worry, chill out. All right. Okay, here's another one. Supriya Sahu again. Explain about Fleming's left-hand rule in force on a current-carrying conductor and magnetic field. Very simple again. According to Fleming's left-hand rule, take your left hand, extend your fingers such a way that your thumb, index finger and middle finger are all perpendicular to each other. The thumb shows the direction of force on the current-carrying conductor. What is the direction of force acting on the conductor? The index finger shows the direction of the magnetic field and the middle finger shows the direction of current. As simple as that, but you need to explain it as well. If you can, draw this 2D figure also if it's possible. Draw this 2D figure as well. That would make it even better. You can just show this diagram also, like a small 2D figure like this that could actually give the feeling to the examiner that you really know your concept. So just try to do that as well if possible, if time permits. Try to do that as well. All right, so that is the next one. Okay, here is another very common question that has been asked by a billion different students by now. Sumbul had asked it again. The question is, so where is the magnetic field the highest in a solenoid? Is it middle at the pole? Now here is the thing. Anup sir told us the magnetic field is highest in the middle. Akir sir told that it is the highest in the poles. So I'm really confused. I totally understand this. See, the common misconception is that the magnetic field of a solenoid is very similar to that of a bar magnet. And you've heard this a billion times already, right? A magnetic field of a solenoid is very similar to that of a bar magnet, and you've heard it a billion times. In your exams also, you're going to be writing the exact same thing. There's no doubt about it. But what you need to understand is that a solenoid is a hollowed structure. It is not filled up. It's a hollowed structure. So there are magnetic field lines clearly passing through the solenoid as well. And if you look at the magnetic field pattern, Inside the solenoid, the magnetic field lines are very, very close to each other and they're also parallel, which means that the magnetic field inside the solenoid is not only strong, but it's also uniform as well. It's both uniform as well as strong. So inside the solenoid is actually where the magnetic field line is strongest in. But here is the thing. Instead, or what I'm going to do is, if I were to place a soft iron core inside, all right, inside the solenoid, if I'm placing a soft iron core inside, this is my solenoid right now, around it I'm placing a soft iron core inside. In that case, near the poles, the magnetic field will be the strongest. Got it? Magnetic field over here would be the strongest when you place a soft iron core inside, or would you put an iron nail inside, because that also gets magnetized. The iron core or the soft iron core or the nail, that also gets magnetized, and then you can say that near the poles it is the strongest. Alright, this is the difference. So make sure that you get that corrected. So why do we multiply area of cross section by 10 to the power minus 4 to convert into meter square? Because see, when you have to convert to from meters to meters to centimeter, 100 centimeters is equal to 1 meter. Alright, 100 centimeters is equal to 1 meter. Now the formula is meter square. Right? If you look at the formula, the unit of area, it's meter square. So when you convert it to, it's meter square, then it's 100 into 100, right? That is why 10 to the power 4. That is why it is 10 to the power 4. Getting it? That's why. I hope you understood the conversion. No, it's meter squared. The unit of area is meter square. No. It's meter square. So when you convert it, you have to multiply both of them. No, it'll be 100 into 100. Got it? Okay. So when power is maximum in series or parallel, power is maximum in series or parallel, you can say that. See, technically speaking, you can say that power is maximum in parallel connection. Parallel connection will be much more higher. But when you talk about power, we don't measure the power in a circuit, but rather we measure the power of a certain device, of an electronic device. We don't really measure the power of circuits as such, but we measure the power of a certain device. All right. So yeah, I mean, you can know this, but technically speaking, we don't really calculate it at all. We only calculate for a certain device. For example, a bulb, find out the power of the bulb, or find out the power of a device. That is what we do. We don't, have you ever come across a question where they have asked you to find out the power is maximum in series or parallel? No, you don't. So it's device, all right? It's device specific. Okay, Karthike, we have done the exact same question. I've done the exact same question. The two devices rating of 44 watt, 220 volt. I've done the exact same question in today's marathon that came out at 10 o'clock in the morning. Check it out. I've downloaded the note. I've put up the notes also. The notes are also put up in the Telegram channel. So you guys can, if you're a part of the Telegram channel, you can download the notes from there as well. But yes, you can find it over there. All right. So you can find it over there. I've already put it up over there. All right. Here's another question, guys. This is a brilliant question. It's a brilliant question. Ashwath had asked this question. The question is, in the network shown below, the ring has zero resistance. The equivalent resistance between point A and B is what? Amazing question. Okay, let me ask you this question. How many of you guys know how to solve this one? After looking, how many of you guys are scared of this question, and how many of you guys immediately had this Mentos wala symbol, Mentos dimag ki batti chala de. How many of you guys know how to solve this? Let's go. So wire of cut into 10 equal pieces, okay, find the resistance of the stretched wire. If they're connected in series, then it'll be 10 R, all right. It'll be 10 equal parts, no? So the resistance also will get divided. See, if there's a wire of 100 ohms, and you've cut into 10 equal parts, and if you're connecting them in series, then the resistance will again be 100 ohms itself. But if you were to talk about each and every part, then the resistance would be different, because 100 gets, if you divide 100 ohm resistor into 10 parts, then each wire has a resistance of 10 ohms. That's what it means. All right. Okay. Now, anyways. Now, not 10 portions. 10 equal pieces also. 10 equal pieces also mean the same thing. So basically the formula is this: R equivalent is equal to N into R. R equivalent is equal to N into R. Now you're cutting them into 10 equal parts. So that means N is equal to 10. R is what you're supposed to find out. R equivalent is 100. So what is R equal to? 10 by 100 by 10. That's all. So it will be 10 ohms itself. No. So each part will have a resistance of 10 ohms. Got it? I hope it makes sense. Okay, all right, so to answer this question, guys, by the way, how many of you guys got this answer? How many of you guys got this answer? 15 ohms, pakka, 100%. Wow, confident, smart learner ji, pakka. All right, let me answer this question. See guys, first you have to understand is that the circular wire that is connected, see the ring that is connected, this ring that you see has zero resistance. All right. Now, if you take these three resistors, this one, okay, what happened, right? Why? Oh, why? I haven't solved it. No. This one, and this one. Tell me one thing, people. Are they all in series or parallel? Are they all in series or parallel? Tell me that first. I'll take this as R1, this one is R2 and R3, and this one is R4. Is R1, R2 and R3 series or parallel? I'll tell you that angry humor, don't worry. Conventional current, no, the current, I'll tell you. It's a very simple definition, I'll tell you that. Pakka, 100%. Exactly, they are in parallel connection. Why? Because current is getting divided. Current is taking three different paths. So current will obviously get divided over here, which means that they are all parallel. So first thing that you have to do is you need to simplify the circuit. You need to find out what is the equivalent resistance between point A and point B. Let's say this is point B. Point B has a resistance of R, which is connected to it. So if you take another point, let's say point A, to this point A, there are three resistors which are connected parallel to each other. Why? Because current is getting divided. Always understand this, people. If you want to know the difference when you're given a circuit like this and you're confused what to do next, always follow the direction of current. Always follow the direction of current. Current will not lie. Current never lies. Direction of current will help you find out which of them are in series, which of them are in parallel. If current is getting divided, then it's clearly parallel connection. If current is not getting divided, then it's series connection. So here clearly it's getting divided into two equal parts, which means it's getting divided into three, you can see. That means that they are all in parallel. Now, here is the thing, people. If this is point A and this is point B, what you need to also understand is that there is a ring that is connecting, which is not connecting this one though, but it is connected like this. Now the thing is, this ring has zero resistance. This ring has zero resistance. So if ring has zero resistance, won't the potential difference at any point be exactly the same or not? If the resistance of this particular ring is zero, will the potential difference at any given point on that circle or on that ring, would it change? Would it be different? It will be exactly the same. So you don't need to even worry about this. You don't even need to worry about this. So all you need to do is, because there will be the same potential difference, there's no resistance. The resistance is clearly zero. So all you have to do is calculate this. Simple. So you have to find out the equivalent resistance. So you don't have to worry about the current and all that. So here it's going to be R1, R2 and R3. How much is this? It's going to be 1 by 6R plus 1 by 6R plus 1 by 6R, which will be equal to 3 by 6R. This is 1 by R equivalent. So what is R equivalent equal to? 6R by 3, which is equal to what? 2R. Simple. Now that you've solved this whole thing is 2R. Now 2R and R are what? In series. Simply calculate. That's all. Bacha question. But the question looks super scary. So you'll get the answer is 3R. The equivalent resistance will be 3R. Got it? Is that clear? Exactly, Karthikeya. Direction of current is not given. You don't need to find it out also, because all they've asked is to find out the equivalent resistance. But what general rule of thumb is that when you have a junction that looks like this, clearly current will get divided. There is no direction of current given. They have not even given that there's a battery connected to it. No, they've not given anything to you. All you need to do is use the general rule of thumb, use your common sense, because at that junction current is clearly getting divided. So if that is the case, then clearly they have to be parallel to each other. Got it? Understood? Makes sense, people? Is that clear? This is actually a very good question. Thank you, Ashwath. If you're watching this, thanks a lot. Hats off, buddy. A brilliant question. All right. Next question. Before I go to the next question, I'll take up some doubts from the chat box, and I'll come back to this one again. So why is always I've already answered that, Malaika. That is, ammeter has lesser resistance, and in series connection, current remains same. So we connect ammeter in series, because in series connection, current remains same. So whatever current flows through the ammeter will flow through the resistor as well. So you can easily measure the current. That is why they're connected in series. Why is the voltmeter connected in parallel? Why? Because in parallel connection, the voltage remains constant, present. And secondly, you're measuring voltage across 2 points, and in order to measure voltage across 2 points, you need to connect them at those 2 points, and when you do that, you would obviously get a parallel connection. And secondly, like I told you, generally a rule of thumb is that in a parallel connection, the voltage remains same, so you can measure the clear voltage difference across these 2 points by connecting a voltmeter which is parallel to it. All right, that is the one. Okay, so difference between conventional and normal current. See, the thing is very simple. Before the discovery of electrons, we had done a lot of different experiments. Electricity was found out way before in the 16th century. In 1700s is when we discovered electricity. When you talk about electrons, on the other hand, electrons were discovered somewhere in the 1800s. All right, 1800s is when electrons were discovered. About 100 years ago, electricity was already discovered. So for a very long time, we assumed that the current is flowing from positive terminal to the negative terminal. All right, positive terminal to the negative terminal. But once the discovery of electron happened, we clearly understood that it is the flow of electrons, not the positive charges, but negatively charged particle called as electron. But the problem was, we had already done so many experiments in the last 100 years. Now we couldn't go back and change everything. So what we decided to do was that if current is flowing, if electrons are flowing from positive to negative terminal, this is the actual direction of current. Current is flowing from negative to positive terminal. But in order to comply with what we had done before, so that, to avoid further confusion from what we had done before, we take the direction of conventional current, which will be from positive to negative. Again, it is just done to follow what we had done, the experiments that we had done during that 100 years time before the discovery of electrons. Got it? So this is what is called as conventional current. Conventional current is nothing but you can say it is nothing but the flow of electrical energy, or you can say it is nothing but the flow of current from positive to negative terminal, or opposite to the direction of electrons. You can say whichever way works for you, that is what is conventional current. Shreyas, you don't have it in your CBSE syllabus. What is internal resistance? You don't have it, but just in case, if you want to understand, internal resistance is nothing but if I take a battery have electrodes in it. You have an anode and a cathode, and there are certain chemicals. If you talk about a dry cell, you have certain chemicals inside of it. So when electrons are flowing from one terminal to another, obviously there will be some resistance inside the cell also, right? It's not that it is free from resistance. Any conducting material will have some resistance. That resistance is what is called as the internal resistance. But you don't have it in your 10th standard syllabus. What is the difference between ammeter and galvanometer? Ammeter is basically a device that is used to measure current. Galvanometer is also a device that is used to measure current. But the major difference is that galvanometer is used to measure the smaller units of current. I'll give you an example. For example, if you go to a goldsmith, they have a weighing machine, right? They have a weighing machine that is used to measure your gold. Now the question is very simple. Can you use a weighing machine that you have in a hospital to measure the weight of a person to measure the weight of your gold? If you have a gold chain, can you use the weighing machine that you use at home or at hospitals to measure your weight to measure the weight of your gold? Is it possible? Can you do that? Can you actually do that? Obviously no, right? Why? Because that machine that you have, the machine that is used by a goldsmith, is well calibrated. They can measure the smaller units also, like that 0.01 gram, because that makes a difference. But in your weighing machine, it doesn't. Like your human weighing machine, it doesn't matter if it's off by 500 grams or up or down. So you see that any weighing machine, what they would have mentioned error can be up to plus or minus 500 grams. 500 grams of gold makes a lot of difference. So that is a well-calibrated machine. In the same way, a galvanometer is a well-calibrated machine which can measure even the smaller units of current. The smaller units of current, even that 0.01, 0.1, ammeter or units of current, that can be measured using these galvanometer. All right, ampere of current can be measured through a galvanometer, whereas an ammeter, on the other hand, would not be able to measure that smaller units. That is the difference. Got it? I hope it makes sense now. Okay, so I'm going to go ahead, solve some more questions. Okay, so here's another one. So thick wire is hanging from a wooden table. All right, an anti-clockwise magnetic field is to be produced around the wire by passing the wire through the current by using a battery. Which terminal of the battery should be connected to the top end of the wire, to the bottom end of the wire, and give reason to your choice? Absolutely brilliant question. I want you guys to tell me the answer, guys. There is a thick wire that is hanging from a wooden table. Imagine there's a wooden table. Imagine there's a table. There's a wire hanging, on the side of the wooden table, and this wire is connected to a battery. All right. Now the question is, which terminal of the battery has to be connected to the top and the bottom if the magnetic field is anti-clockwise direction? Put it out in the chat box now. Quickly. So can you give the conditions where the galvanometer deflects, please? See, for galvanometer, for it to deflect, there has to be current produced in it. Now, galvanometer is generally used in to show electromagnetic induction, because during electromagnetic induction, the current produced is very less. It's very, very small. It's very negligible. So that is why we use galvanometers over there. But again, in order for current to be induced, there are certain conditions. There has to be a relative motion. There should be a magnetic field. There should be a galvanometer connected to it. So all of these are the conditions. All right. Okay. Top negative, bottom positive. Pakka Lakshana. Array, awesome. Okay. Now to answer this question, guys. See, first problem that a lot of you guys might end up making is that you do not look at the point of view. See, generally when you have a conductor like this, you are talking about the top view. Alright, you are seeing from the top. You are seeing from the top, not from the bottom. This is the first thing you need to understand. You're seeing from the top. So if you are seeing from the top and the magnetic field is given in anti-clockwise direction, that means current is going in the upward direction. Current is going in the upward direction because it is an anti-clockwise. So when you see from the top, it's an anti-clockwise direction. Getting it? Are you able to understand? So this is the first mistake you need to correct. You need to understand that you're seeing from the top here. You are actually seeing from the top. So if that is the case, then current has to be coming towards you in the upward direction in order for you to see that the magnetic field is in anti-clockwise direction. If that is the case, very simple. So this should be the positive terminal. This has to be in the negative terminal. Why? Because current is going in the upward direction for you to get that anti-clockwise movement. So that means that at the top of the wire, you would be connecting the negative terminal. At the bottom, you'd be connecting the positive terminal. Alright, the reason I just explained it, so you can go with that. Alright, so positive terminal would be connected at the bottom and negative terminal would be connected at the top. Got it? Clear, people? Understood? Clear. Got it? Hi, social science, what's up? Social school, what's up? Current, that's what Krishna, see, they have clearly mentioned that the magnetic field is in the anti-clockwise direction. You are seeing from the top. So when you see from the top, okay, I'll just make my screen full screen so that you understand this. The current is going you have to see the magnetic field is in the anti-clockwise direction. So if current is going in the downward direction, when you see from the top, if you look at your fingers, they are in clockwise direction. When you see from the top, they're in clockwise direction. Getting it? But on the other hand, when current is going in the upward direction, current is going in anti-clockwise direction when you see from the top. That's why. Got it? I hope it makes sense now. You need to remember, you need to understand all of this. You need to remember all of this because obviously you would definitely have certain questions like this. 100% you'll have questions like this. Alright. So make sure that you remember all of this. Alright. Moving on, guys. Moving on now. Alright. Next question, people. Next question was next questions were asked by Vinod Kumbar. Vinodji, if you're there. Can we have a big round of applause for Vinod? I'll just show you how many questions Vinod has asked. Vinod has asked not 1, not 2, not 3, but 10 questions. My boy Vinod, if you're watching this, wah bete wah, as Shilpi ma'am puts it, pura paisa vasool. Alright, I'm going to solve these questions one by one. I'll try to solve all these questions. 10 questions, so I'll do my best. Alright, I'll do my very best. First question is, what is meant by high and low potential? What does potential difference indicate? High potential means the place or the point where there's an accumulation of positive charge. Where there's an accumulation of charge, you can say, is nothing but higher potential. Where there's less accumulation of charge, where there's lesser number of charges, positive or negative, that is what is called as lower potential. Generally, positive charge is considered to be at higher potential, negative charge is considered to be at lower potential. So you can mention that also if you want to. High potential means where there are more number of charges, low potential means where there are less number of charges. What does potential difference indicate? Potential difference indicates basically how the movement of current is going to be. It helps you to show the direction of current or the flow of current. What is potential difference? If you're asking what is potential difference, it is nothing but the work done to move a unit charge from infinity, or you can say from one point to another. That is potential difference. The work done to move a unit charge from one point to another, that is what is called as potential difference. Second one, how to find the slope of a VI graph. Absolutely, this question will not be asked. 110% you'll not be asked, because it's basically a math problem. You will not be asked that. But just for the sake of knowledge, I can tell you this, that if you have a VI graph, basically your voltage versus current graph, if you want to find out the slope, the formula for slope is what? M is equal to y2 minus y1 divided by x2 minus x1. So basically this is called the 2-point formula. You take any 2 points, find out the slope. You will definitely not be asked. But if you want to know what do you get when you find out the slope, the answer is resistance. You will find out the resistance of a circuit when you find out the slope of a VI graph. All right, next question. How current in series combination remains constant but voltage doesn't? The answer for that is also very simple. In series connection, current does not have any other path to take. It follows the exact same path, the same amount of current, the same charges or same electrons are flowing through this resistor as well as this resistor. It does not have any other path. You have a straight line, you have a straight road from your place to your friend's place. What else will you do? You have to take that path. Even if you don't like it, you're going to take that path itself. That is why current remains same in series connection, because there is no other path for current to take. It has one single path. It has to take it. There is no other choice. That is why current remains constant in series connection. All right. Voltage doesn't. Why? Because voltage is nothing but, again, the potential difference across 2 points. It is nothing but the work done to move a unit charge from one point to another. Now, if I take these 2 points and these 2 points, please pay attention, guys. The work done to move this charge from, let's say there's a charge over here. To move it from here to here, the work done will be comparatively different, or it'll be absolutely different in comparison to the work done to move this charge from here to here. This is why potential difference does not remain constant. Why? Because the potential difference is actually getting divided here. It is not going to be the same. If you have connected a 6-volt battery to this circuit, that 6 volt can get divided as 3 volts and 3 volts. All right, because the work done to move a unit charge, again, this I'm talking about in terms of electrons. If I talk about an electron, the work done to move it from one point to another will be different in comparison to the next one compared to this. Why? Because resistance is higher. Resistance is higher in series connection. All right, V is equal to I into R. All right, so since resistance is higher, you have to do more work. So V is directly proportional to R, right? More the greater the resistance, you can say that you need greater potential difference to do the same amount of work. So you can say that in that case, you can clearly say that there's greater amount of work done. Why? Because the resistance is also much more higher. All right, makes sense. Okay, I'll clear the doubts now. I'll just clear all of these as well. All right, next one. Why is tungsten used most exclusive? Okay, wait. Explain 2 advantages and disadvantages of each series and parallel combination. My God, series combination. The advantage is that current remains same. You can say that the current remains same. That is one advantage. And in series connection, you can say that the advantage of series connection, there are not many. You can say that the current remains same. Apart from that, you can say that if you want to increase the resistance in a certain circuit, you want to increase the resistance so that device can work safely. In that case, we use series connection because you want to increase the resistance. So in that case, the equivalent resistance in series connection will be more. So it will be much more higher. Disadvantage of series connection is that the potential difference is divided. So current will be comparatively lesser in series connection. And secondly, even if one device stops working, the others would also stop working in series connection, because again, current does not have any other path to take. In parallel connection, however, current has different paths to take. So even if one gets disconnected, the others would continue to work. So that is the advantage of parallel connection. Voltage also remains the same in parallel connection. Next one. Why is tungsten used most exclusively for filament of electric lamps? The reason is because of it has a very high melting point, and 2 reasons for it. One is that it follows a property of a material called as incandescence. What is incandescence? Is nothing but when there is too much resistance, or when there's too much current flowing through a circuit, or when you can say that when there's too much resistance, or when there's current flowing through the circuit. When there's too much current flowing through the circuit, what will happen is that metals generally glow. They glow. Incandescence means they can glow. So that is basically when you heat, when you reach a very high temperature. So you know that heat energy is directly proportional to the resistance. So greater the resistance, greater the heat energy produced. So tungsten has high resistance, because of which it is able to reach that temperature very quickly, and it also produces light. So incandescence is one. Second is that it has very high melting point. The melting point of tungsten is around 3422 degrees Celsius. So it has a very high melting point. So it does not easily get disconnected also while you keep it on for a very, very long time. All right. So that's one more thing. Hi, Kirtana. What's up? Next question. My God, Vinod. Okay, I'll just take a small break. I'll take one more doubt from you guys. So, so in resistance question, if we have to make if we have to make the resistance diagram once more after evaluating the resistance or not, you don't need to Pragati, but it'll be nice if you could do it. That is a very good question though. While you're writing if they've given you a very complicated circuit and there's a lot of calculation you have to do and you have to simplify the circuit, is it good to draw the circuits over and over again? If you ask me, yes, it is, because it gives the examiner a clear indication that you've clearly understood the question and you know what you're doing. It won't take much time, but yes, make sure you use a pencil. Use some pencil which is a little darker in which can be which is not which is a little darker, that you have these 2B, 2-3 pencil and all that. No, use a little darker pencil so that you clearly can see it. And secondly, make sure you draw it so that it gives a clear indication to the examiner that you know what you're talking about. All right. Individual switches is possible? Yes, it is absolutely yes. Even double switches are possible. Sir, what about circuit breakers? Is it there in our syllabus? Circuit breakers, no, you don't have, but yeah, you don't have it. Fuse and everything has been removed, no, so you don't have it. So please explain the mechanism by which chromosomes. Satyaji, good question. Chromosomes number, no? I'll explain it. Give me another 10 more years. I don't teach biology, da. Alright, so okay, I'll go to the next question. Which question? This is the one. Why are the conductors of electric heating devices such as bread, toaster and electric irons made up of alloy rather than pure metal? Very good question again. Why are they made up of alloys? Because alloys have higher resistivity. So because of which they can actually produce a lot of heat energy. That is why they are used, and alloys generally have higher melting points also. So these are the two reasons why we use alloys instead of pure metals, because alloys you can actually increase or decrease the combination of different metals to adjust it to make it to your preference, and for that reason they have higher melting point, and secondly they have very high resistivity compared to metals. Next one, how to identify in which direction the needle of compass move if the current in conductor is flowing in north-south direction. So there are two ways to find out the direction of current flowing in a conductor. One is your Maxwell's right and thumb rule, or simply put right and thumb rule, where the thumb shows the direction of current and all the enveloping finger shows the direction of magnetic field. That is one way to find out the direction of the magnetic field. The second one that you can use is your compass. So what you do is that you take a straight current carrying conductor, there will be a magnetic field produced around it. So what you do is that you place the compass around it. So when you place the compass, the needle of the compass will point in the direction of the magnetic field. So you can plot the entire magnetic field's direction using a compass. All you have to do is place it at different position. So every position you keep, the needle of the compass will change. If you plot it accordingly, you can find out the right direction. Alright, so that's one more thing. Next one is, what is the direction of magnetic field at point above and below the current carrying conductor in a current flowing, if the current is flowing from left to right direction? Good question again. Again, you have to use Maxwell's right and thumb rule. So hold a straight current carrying conductor such a way that, use your pens in your exam halls, use your pens. So you have a current carrying conductor in which the current is going from your left to your right. It is going from your left to your right. This is the direction of current. So if this is the case, above and below, what is the direction of magnetic field? Above, the magnetic field is going from north to south. So you can say it's going in the southward direction. It is going from north to south. Below, on the other hand, it is going from south to north. So above, it is going from north to south, because if you look at the enveloping fingers, it is going from north to south. Below, it is going from south to north. Got it, people? Is it clear? Am I just talking to myself right now? Is it clear? Able to understand? Am I going fast? The reason I'm going fast is because people, I want to clear all of your doubts, but it'll not be possible if I'm going a little slow. That's why I'm hurrying it up a little, but I hope it makes sense. So if you have straight current carrying conductor, again, if you look at the enveloping fingers, it is going like this, it is going like this. So from above, it's going from north to south, or you can say it's going in the southward direction. From below, it's going in the upward direction, towards the north direction. All right. Yes. See, if you have any questions which is out of syllabus, don't attempt it. Try to avoid it if possible. But if you feel like CBSE is going to give you marks nonetheless, I would say do not try to avoid those kind of questions as a whole, because you never know what CBSE is going to decide at the end of the day. Because those kind of announcements of whether a certain mark would be given for a certain question which is out of syllabus, that discussion comes later. So don't depend on that. I would say don't depend on that at all. So make sure that you guys give your best to, I would say, ignore it for now, and choose a question which is there in your syllabus. Why to take that risk, right? Why to take that risk? Try to avoid it as much as possible. All right, here's another one, guys. What is the direction of magnet? Okay, I've done that. In which direction or the needle of the galvanometer will deflect if the magnet is brought closer to the wire? How to identify that? Very simple. Fleming's right hand rule. Using your Fleming's right hand rule, you can find out in what direction the current is going to flow, and depending on what direction the current is going to flow, you can tell which direction the galvanometer is going to deflect. So what is Fleming's right hand rule? The thumb shows the direction of the you can say the force on the current carrying conductor, or the force on the conductor, or the motion of the conductor, or the magnetic field. The index finger shows the direction of magnetic field. The middle finger shows the direction of induced current. So the middle finger will help you to find out the direction of the needle of the compass, because whichever direction of the current is, the galvanometer will also deflect in that very same direction. All right. Next one. What happens in the wire if the magnetic field is altered such that it produces an induced current? What happens if the wire, if the magnetic field is altered such that, what will happen to the wire? There will be current induced. Because of the current induced, there'll be a deflection in the galvanometer. That is what is going to happen. It's not going to catch fire. No, it's not going to catch fire. It's not going to start dancing for Jumma Kalakadi Jumma Jumma. It'll obviously have induced current. That's all. Nothing else is going to happen. All right. What will happen? It's induced current. That's all. Current will be induced. Potential difference will be induced. That's all. It's not going to start dancing. Okay. The last question, guys. Last question for today. I believe this is the last question. Last question. After that, I'll take up your doubts in the chat box. Here's one. Is it necessary to draw diagrams in electricity questions where we have to find out the total resistance or total current? The answer is a big fat yes. Please do. It makes your life a lot easier while you're doing the calculation. If you get it wrong, you can always trace back your steps. Secondly, it also makes the invigilators or the examiner's life also a lot easier. So please draw diagrams. Carry your pencil. Don't forget to please carry your pencil. Please don't do this. Don't do this, that go to your exam hall and ask your friend, do you have a pencil? Do you have one extra pencil? Do you have one extra pen? Don't do this. All right, don't do this. Don't do this at all. At least for this exam. All right. I know a lot of you guys fall in this category. At least for this exam, final exam, please carry your own pen, pencil, eraser, sharpener, scale, anything and everything that is needed, except for chit and chits in the sense, copy chits, the formula chit sheet and all. Don't carry that. And your calculators. Don't carry these both. Apart from that, carry everything else that you need, because you can't ask someone in the middle of the exam. It doesn't sound right. It doesn't give a good impression. So don't do that. It's an exam. So take it with all seriousness. Unlike your school exams and all that, this is way more serious, because in most schools, invigilators would be coming from different school, right? They'll be coming from different school. Do not give them a bad impression, right? So don't give them a bad impression at all. All right. So do you have to draw diagrams even for 2 markers? Yeah. Try to do it. If you have time, try to do it. But if you don't have time, if you feel like you can solve it in one single step, then don't do it. If you can solve it in, like, for example, they've asked you what is the value of current, or what is the value of potential difference, then don't do it. Direct answer. Don't have to do anything. Directly put it down. But if it's a 3 marker or a 4 marker where they've asked you to calculate, then please draw the circuit diagram as well. It makes it a lot more easier. Always ray diagram. All right. Okay. Any other doubts, guys? How to calculate numericals, Bhupati? I would say use as much short tricks those turbo math, Vedic math and all you've done, right? Use as much short tricks, but in your examination, use those short tricks to cross check your answers. But in the answer sheet, please, I'll tell you one thing: draw a rough column. All right, especially in science, especially when it comes to physics, please draw a rough column. It makes it a lot cleaner. It's a cleaner representation. So do this, carry your pencil, and as soon as you get the question paper, what I would say is this is what I used to do. Honestly, I used to do this for every exam of mine, because first of all, we didn't have rule sheet. We used to have this white paper, so it was very important for me to, because my handwriting goes like this. It goes from Bangalore to Mumbai. I always sit like this. It goes from Bangalore to Mumbai. So instead, what I used to do is that I used to draw this for every exam. So draw proper margin. It makes it look a lot cleaner. All right. So draw the margin. Use the rough column. Make sure you write it as rough column so that they don't use it. So the rough column can be used to do the cross checking and everything. But while you're doing the calculation, while you're doing it, please show every single step. Every single step you need to show it. Why? Because people, steps carry marks. Steps also carry marks. So if in case you for some reason were not able to find out the final answer, or you do some calculation mistake and you get it wrong, at least 3/4 or half of your marks you'll be getting. No, at least half the mark that you'll be getting. If it's a 4-mark question, at least 2 marks, 2 rupee systems. 2 marks is guaranteed. 2 marks is guaranteed. At least that much is guaranteed. Alright, so please show every step. Alright. Sir, how to use hand rules correctly? Avantika, practice. No other thing. Practice. Go to the past 5-year question papers. Past 5-year question papers. Past PYQs. Past 5-year question papers. Solve every single hand rule. Solve every single hand rule question that is there. You will hardly find 10 of them. Hardly 10 of them. Try to solve one. You won't even find 10. I'll tell you, you won't even find 10. Whatever is given over there, try to solve that at least. At least that you need to do it by now. So can you please tell the definition I need to learn for physics? Kaja, definitions though, you need to know the definition of Ohm's law, you need to know the definition of Joule's law of heating. In magnetism, you need to know the definition of, all the 3 hand rules, how to write it properly, you need to know that. Electromagnetic induction, EMI, very, very important. Go through the definition of that as well. Alright, super duper important. Go through all of that. So P is equal to I square RT. Okay. Yes, Swastika, very good question. So this is a very common question that I keep getting all the time. Sir, P is, okay, let me just create a new slide, guys, so that I can write something. Just give me 1 second. How do you, yes, no slide. Okay, so just give me a second, people. I'll just create one more new slide just in case. 2-3 new slides. Okay, so that I can clear your doubts, all right? Okay, so first thing first, P is equal to I square R and P is also equal to V square by R. Now the question is, sir, which of this is true? Is P directly proportional to R or P inversely proportional to R? The answer for this question is very simple, people. If current is given in the question, then go with this relationship. If current is constant, then P is proportional to R. If voltage is given in the question and voltage is constant, then you can say that P is inversely proportional to R. So it all depends on what is given in the question. It's very dynamic. Alright. If current is constant, then P is proportional to R. If voltage is constant, then P is inversely proportional to R. Got it? Makes sense? Any other ask? Sir, why if current flows from north to south, the compass needle gets deflected towards east? See, the reason that's a very good question. Absolutely fantastic question, Mohammed. Sir, if you have current flowing in south to, let's say this is the north pole, this is the south pole, current is going in north to south direction. Why does the compass needle deflect towards east? Why? Because when current is flowing through a conductor, there is a magnetic field created around it. The compass is showing the direction of the magnetic field. Understanding, it is not pointing towards the polarity of the conductor, but rather it is pointing in the direction of the magnetic field. Got it? That is why. Clear? Understood? This is why. Because it is pointing in the direction of the magnetic field, not that it is pointing towards. It is not pointing towards the north pole of the of this thing of the conductor. It is pointing towards pointing in the direction of the magnetic field. That's why. Okay, sir, if current is produced but not moved, will current be produced in the second circuit according to EMI? If current is produced but not moved, absolutely yes, Tejas. So if you have 2 circuits like this, let's say this is the primary coil, this is the secondary coil. The minute you turn on the switch, what happens is that there is a magnetic field created because a current carrying conductor has a magnetic field produced around it. That's what you have learned, right? because of that sudden increase in the magnetic field, there will be current induced in this conductor. There will be a deflection in the galvanometer. But that deflection is going to be momentary. It is going to be momentary. It is not going to stay for long. It is only going to stay for a couple of seconds. That's all. After that, it will again come back to normal. Again, when you turn it off, again there will be a deflection, but this time the deflection will be in the opposite direction. Again, that is also going to be momentary. Momentary in the sense, it's only going to stay for a couple of seconds, not more than that. Alright. So can we draw diagrams using pen in exam? Please don't do it, Priyanshu. Don't do it. Please don't do it. Humble request. हाथ जोड़ के कहता हूँ, don't use your pens, use your pencils. For your diagrams, use only pencils, don't use your pen. Two things, when you draw using your pen, it basically leaves a smudge in a sense, it leaves a mark. So the paper behind also will have a clear mark on it. Don't do that, because you have to put a stress on it. Use your pencils, it's a lot better, it's a lot cleaner, and even if you make a mistake, you can erase it and draw it again. Again, don't scribble, make waves in your exam sheet. Don't do that. All right. Don't create ripples and all in your exam sheet after writing something. That gives a very bad impression. Because when you have a lot of scratches on your paper, that shows that your mind is not clear. Getting it? This is what the impression goes. It shows that your thoughts are not clear. That leaves a very bad impression on the examiner's mind. So don't do it, because your examiners don't know you. They have never seen you before. They don't know who you are. They don't even know your name in most cases. Only a roll number would be visible. For us, at least, it was that. So if that is the scenario, then don't do this to yourself. All right, don't dig your own grave. So try to keep it clean as much as possible. So form the sentence in your mind, then start writing. All right, don't start writing and then cut it and then again start writing it. Don't do that, because it leaves a bad impression, and you are not allowed to carry any whiteners also, so it'll stay there forever. All right. So what does it mean when we say alloy do not oxidize easily at higher temperature? Mohammed ji, I'm not the right person to ask this question to. Shilpi ma'am is the right person to ask to. So I would say please ask Shilpi ma'am or Anubha ma'am in 99 Hindi channel to get it solved. I'm really not the right person to solve this. So if a question comes on EMI for 4 marks, then do you have to do? Absolutely yes. Absolutely yes. 4 mark EMI means definitely draw the diagram. Do not miss it. Draw the entire. Go explain the whole thing. 4 marks means write the whole Jataka of his, Jataka in the sense, their whole, family tree of the last 10 generations, right? Everything. Connect a galvanometer, take a magnet, draw the magnetic field of the magnet, show the polarity of the magnet, everything. Show everything. 4 mark question, electromagnetic induction, show everything, don't leave anything at all. So, okay, anything else? So, resistivity question, Mamaji, resistivity, so what is your doubt? Please tell me. So temperature effect, absolutely yes, absolutely. Temperature affects resistance of every kind of material, not just alloy, even metals also, because when you increase the temperature, the entropy increases, or entropy in the sense, the randomness increases. So because of the randomness, increase in the randomness, what would happen is that the electrons will collide more number of times, because of which the resistance, there's a lot of loss of energy happening, so resistance also increases. All right, that is why in Ohm's law, while you're explaining Ohm's law, you have to mention that Ohm's law is only valid when the temperature is kept constant. You need to mention that temperature is kept constant. You need to mention that. Again, it's an added sprinkle. All right, do that as well. Please explain motor in short. Avantika, motor is a very simple device that converts chemical energy to mechanical energy. How does it perform, or how does it work is by this. So you have 2 magnets, one permanent magnet, which is the north pole and the south pole. There's a conducting coil placed between the magnet, and there is a split ring connected at the end. The split ring in turn is connected to 2 carbon brushes, which is then connected to the external circuit. So how does it work? Very simple. When you turn on the switch, you can also place a switch if you want to. So when you turn on the switch, current starts flowing through the device. It passes through the carbon brush, from the carbon brush into the split ring, and then into the conducting coil. Now, from what we have learnt before, that is Lorentz force, we know that when a current carrying conductor is placed in a magnetic field, it will experience a force. So what will happen is that since this whole circuit A, B, C, D, the conducting coil is placed within the magnetic field, right? There are magnetic field lines moving from north to south. what would happen is that AB will experience a force in the downward direction, whereas CD on the other hand will experience a force in the upward direction, and hence again you have to use Fleming's left hand rule. Show it as well. I'm not showing it right now. You can write the entire thing. So you're going to use Fleming's left hand rule over here. Fleming's left hand rule you're going to use, and using that Fleming's left hand rule, you can say that AB is going to go downwards. BC and AD will not rotate. It will not experience any torque whatsoever, any rotational force. Why? Because BC and CD are both parallel to the magnetic field. Since they're parallel to the magnetic field, they will not experience any force. But AB and CD will, so not CD, sorry. This is AD, my bad, AD. BC and AD will not experience any force, but AB and CD will. CD will go in the upward direction, AB will go in the downward direction, and it will continue to rotate, and the split ring will help in the change in the direction of current, and hence split ring is also called as a commutator. All right, simple definition, a simple way. Sir, chemical energy and electrical energy. It converts chemical energy, or you can say electrical energy makes sense. Chemical energy, what I meant to say was battery. All right, I was talking about the battery. Yeah, you can say electrical to mechanical. That actually makes more sense, because it's not always that you connect a battery to it. So don't think, okay, if you think about battery, when a battery is placed, it is converting chemical to electrical to mechanical. But if there's no battery, and most cases they don't ask about battery, by mistake it came out, so you can just say electrical to mechanical, directly write as electrical to mechanical. All right, function of split ring, function of split ring is to change the direction of current. So what happens is that when current is flowing, see AB will go up, right? I'll just show it to you. I think I don't have the box with me right now, but unfortunately I don't have it. I'll just show it with this one, guys. I hope this would help. Imagine that this is a simple conducting coil, right? And to this conducting coil, there are two split rings connected, all right? So there's A, B, C, and D. So what happens is that when it starts to rotate, the split ring also rotates. Because of the rotation of the split ring, the direction of current changes. So what will happen is that initially, if you were to, I'll take it as B1, brush number 1 is B1, and this is B2, brush number 2. I'll take this one as X and Y, split ring as X and Y. So initially, what is the direction of current? Current flows from B1 to X to A, B, C, D. Then it will go into Y and then to B2. But after it has completed half a rotation, this is half rotation. Once it has completed half a rotation, the direction of current will change to B1, it still remains B1, B1 to Y to DCBA, alright, then to X, then to B2. So direction of current is changing because of the split ring, alright. That is why it is called as a commutator, alright. Okay, oh my god, so sorry. I was just writing all this while without showing the screen. Oh my god, I'm so sorry. I wrote the whole thing and I didn't. Okay, I'll just show it one more time, guys. I'll show you it one more time. So this is the direction of current right now. I'll just draw the whole thing one more time so that it avoids confusion. This is the split ring. I'll take it as X and Y. All right, carbon brush. I'll take it as B1 and B2. This is B1. This is B2. All right. So here I've connected the battery to it. All right. Very sorry, I forgot that I put myself on full screen, A, B, C, D. So if this is the case, this is the North Pole and South Pole. Initially, when the current is flowing, current will flow from here, positive to negative terminal. So from here to B1 to X to A, B, C, D. Then see A, B, C, D, the direction of current. Then it's going to flow to Y, right? Then from there, it's going to flow to B2, and then finally, it will go back to the negative terminal of the cell. Once it completes half a rotation, now the direction of current will change to B1, DCBA, alright, DCBA, then to X. Sorry, I forgot to write X over here, so Y over here. So from B1, it will flow to Y. From Y, it will go to DCBA, I forgot the split ring, Y, then to X, then to B2. So this direction of current is, changing because of the split ring. Got it? Alright, yes, anything, as long as you are able to understand, it really doesn't matter. Hindi or English, it really doesn't matter. I really don't care about that. Sir, would it be better to go with physics first and then, so as whichever you find is easier, go with that. I would say, If you find biology easy, start with that first. If you find chemistry easy, start with that first. But again, over here also you have to think about the sections that you use. But whatever section you start off with, try to stick to that itself because it gives you a cleaner impression. Try to stick to one particular thing and get that solved, all right? But yeah, whatever you find easy, start with that and then go with the rest, all right? I know. Thank you. So would it be electromagnetic induction? Mohammed ji, electromagnetic induction is nothing but when you have a conducting coil or a solenoid or a conducting, like it's a conducting coil. When you have a conducting coil linked to a or you can say when a moving magnetic field, you can say it like this. I think the best definition for electromagnetic induction is when a moving, I'll just write it as cleanly as possible. When a moving magnetic field is linked to a conductor, there is a potential difference or a voltage induced in the conductor. This is what is called as electromagnetic induction. Got it? So this is the textbook definition. It actually makes a lot of sense if you can remember it. Otherwise, you can just say when a current carrying conductor is placed near a moving magnetic field, there is a current induced in the conductor. That is what is called as electromagnetic induction. Time management tips, Ananya, I would just say this, guys. For time management, this is the thing that I would say. All right, please make it a magnetic. It's management. All right, management tip, what I would say is, first of all, start with questions that you know. Whatever questions you know, start with that. All right, don't start with the unknown questions, start with the known questions. Secondly, last 30 to 40 minutes, the last 30 to 40 minutes should be kept for questions that you do not know of. Those questions which you do not know, stick to this last 30 to 40 minutes because you'll have enough time to think clearly and answer this, and maybe while you're writing the answer itself, you might remember it, so you can use the last 30 to 40 minutes to write the answers which you find a little difficult or a little confusing. You can use that. Apart from that, make sure you don't spend more than 2 to 3 minutes for 2 markers. All right, if it is taking more than 2 minutes, then go to the next question. All right, go to the next question, come back, visit back, leave some space, visit back the question once you're done with it. All right, that is if you've already started writing. If you feel like you're not able to think clearly, come back to this question later. For 3 markers, do not spend more than 5 minutes max. 5 to 8 minutes max. Don't spend more than that for 3 markers. Lastly, for 5 markers, do not spend more than 10 to 12 minutes. 8 to 12 minutes max for 4 markers. Not 3 markers or not 5 markers, 4 markers. Do not exceed that. Try to stick within that. If any question is taking more than that, then please stop right there. Come back to this question later. Do not force yourself and break your brains. All right, do that. So will increase in area of conducting coil increase the rotation speed of motor? Yes, you can. Yes, instead of doing that, all you can do is increase the number of turns rather than increasing the area itself. Increase the number of turns. If you increase the number of turns, that will also increase the speed at which the coil rotates. Especially in commercial motors and all, they will have a lot of copper coils, right? The more number of coils that you have, more would be the amount of current more will be the amount of force experienced by that conductor. All right. Definition of potential difference. Binda, potential difference definition is nothing but the work done to move a unit charge. The work done to move a charge from infinity to a point, to a definite point or to a point. That is what is called as potential difference. All right. Sir, sure, how would you join 3 resistors each of 9 ohms so that the equivalent resistance of the combination is 13.5? Again, this type of question, Ashwath, I've done a lot of this, but this is all trial and error. It's all trial and error method. It's all trial and error. You have to try out different combinations. So you have 3 resistors all connected in all out of 9 ohms. You have to initially get the resistance as 13.5 ohms. So I would suggest you to try this out first. Try connecting 2 of them in parallel and 1 in series. How much will you get? Try to find that out first. So this is going to give you 1 by 9 plus 1 by 9. I'll just make my screen a little short. 1 by 9, so this is going to be 2 by 9. That's going to be 9 by 2, 2 4s are 8, 4.5. So 4.5 plus 4. 4.5, array, 4.5 plus 9 will give you 13. Alright, so this is one way to do it. Alright, so try again, it's all trial and error. It comes with a lot of practice. So you get us 13.5 ohms. Easily you can say two are connected in parallel, one in series. Now for the other one, what is it? 6 ohms. So if you want 6 ohms, you can try connecting them all in parallel. Try doing that when you connect, because the equivalent resistance is less than individual resistors. So it's going to be 1 by 9 plus 1 by 9 plus 1 by 9. That is going to be 3 by 9. So it's going to be 9 by 3. 3 is a 9. Okay, so you can't get that. Then you can again try out different material, this thing. So this is going to be 3 by 9, 3 by 9. So 3 is a 9. This is going to be 3 ohms. All right, so this is not the right one. Again, if that is the case, then try another combination. So you have already done this. Now you can try 2 series and 1 parallel. 2 series and 1 parallel. Try this one also out. 9 plus 9. Again, it's all trial and error. It is all trial and error. So this will give you 18 ohms. 9 plus 9 is 18. So it's going to be 1. The equivalent resistance will be 1 by 18 plus 1 by 9. 9, 2. So it's going to be 1 plus 2 divided by 18. So it's going to be 3 by 18. So it's going to be 18 by 3. 18 by 3. 3, 6 by 18. So 6 ohms. Got it? So it's all trial and error. It's all trial and error. You have to keep trying out different combinations. Whichever works best, go with that. Alright, so resistivity question, how to start, please help. Chitra, resistivity question, to see the formula is very simple. R is equal to rho into L by A. So resistivity is equal to what? R into A divided by L. That's all. Substitute the values. If you know the value, substitute that, get the answer. That's all. Alright. Oh, is it? Arey, nice, Anvesha. How was it? Arey, awesome. I'm really sorry, Anvesha ji. ICC, though, we completely forgot. But how was it? How was the exam? Was it good? So, our poles and polarity is same. Yes. Pole and polarity is the same thing. So, please define splitterings and carbon brushes. Splittering is nothing but, it's a conducting coil which is, cut in half, or you can say is divided in half, which helps in changing the direction of current. It helps in the changing the direction of current. And splittering is basically the one that is in contact with the carbon brushes. Alright, splittering is the one that is in contact with the carbon brushes. Carbon brush, on the other hand, is basically made, brushes on the other hand, is made from graphite, which is always in contact with, or which is stationary, which is a part of the stators, in the sense they do not really move. So these carbon brushes form the connection between the internal circuit and external circuit. In the sense, the conducting coil that is there, or the armature coil, that is connected to the external circuit. External circuit in the sense, the battery and everything. That connection is made through the carbon brushes. They are the connecting link between, or the bridge between the external circuit and the internal circuit. Got it? So how can you find displacement in velocity time graph? Alright, displacement in velocity time graph, area under the curved arch. Area under the curve will give you the displacement. Day 9 standard. So how do you, you make me confident in exam. Thank you, Hacks D. No worries. Molvina's homogeneous, and I'm really not sure. I don't teach biology, I teach physics. I do not know the answer for that. So why are freely suspended magnets rest in a particular direction? Why so? Okay, Avantika, that again is very simple. See that the earth itself, earth has a core, right? Earth has a core. The core of the earth is made from, it contains a lot of iron and nickel. Because of which the core is magnetized. So you can say that the earth itself behaves like a huge bar magnet, alright, where the north pole of the bar magnet of the earth is in the Antarctic circle, which is basically in the south pole, and the south pole of the earth is in the north pole, that is basically the Arctic circle. Alright, Arctic circle, Antarctic circle, or the north pole of the earth, geographic south pole of the earth. Because of which, when you place a magnet, when you suspend a magnet freely, what will happen is that the magnet will automatically align itself to the magnetic field of the earth. This is why it rests in a certain position, such a way that the north pole of the magnet will point towards the geographic north pole of the earth, the south pole of the magnet points to the geographic south pole of the earth. Hacks on Malayalida. So how to crack numericals? Mulvinas, numericals, first thing that you need to do is, again, I'll just create some more, lots of doubts are coming in, 10 more, I'll clear some more doubts and then I'll leave. Again, last stretch, no? So let's just finish it off. How to crack numericals? See, I've been always not great at math. Honestly, I've been never great at math. But one thing that I always found helpful when it comes to numericals, for all those people who are like me, who find math a little difficult, right? The first thing they need to do is write down the given data. Why am I saying this? Because this given data will give you at least a clear picture of how to approach this question. First thing, write down the given data, make it a practice. Do not leave this. Write down the given data. Whatever smaller detail is also given, write that down. Given data is first. Second thing, write down the formula. What formula you have to do next. Then substitute the values. If you do this itself, even if you get the final answer wrong, you will still end up getting 3/4 of the marks. If you do this much alone, you'll still be getting 3/4 of the marks because there are step marks in physics. Alright, please do that. So difference between series and parallel connection. Series connection is where the resistors are connected, or the resistors are connected one after the other, where the current has one single path to flow, where current is constant but voltage is not, or potential difference is not. Parallel connection is where they are connected, where both the ends of the resistors are connected. In this case, voltage remains same, but current is different. You can also write on the formula. Here R equivalent is equal to R1 plus R2. Here R equivalent is equal to 1. So 1 by R equivalent is equal to 1 by R1 plus 1 by R2. That is the formula. Alright. Oh, is it? Hare, thank you, Anvesha ji. Thank you so much. Thank you so much. I hope your results comes out really well. All the best, Anvesha. All the best. So in which direction of current, actual and conventional current is used in hand rule? Always follow the conventional current. Tanu? The conventional current. Always follow conventional current, guys. In your hand rules also, always follow conventional current. Conventional current itself. I'll give you an example. Alright, for example, let's say there's a question given in which there is an electron beam going from left to right. There is an electron beam. They've given in the question that there is an electron beam going from left to right. You are asked to find out the force on this electron beam. Now tell me, people, when you point your middle finger, will you point from left to right direction or from right to left direction? If they have given you that there's an electron beam going from left to right, which direction will you point your middle finger in? You will point it in the opposite direction. Opposite direction. Why? Because you will always take the conventional current. Right to left will be the pointing of your middle finger. Got it? Always do that. Alright. How to do heating effect? Remember the formula. Very simple. The formula is what? H is equal to I square RT. This is the basic formula, but this is Joule's law of heating, but there are several other formula also. I would say remember one formula. H is equal to VIT. This is the basic formula. Vellore Institute of Technology. That's how I remember it. VIT. There is an institute in Tamil Nadu called as Vellore Institute of Technology. Remember it like that. H is equal to VIT. Now, here you're going to use Ohm's law. Use Ohm's law. Alright, use Ohm's law over here. So we know that V is equal to I into R. So you can say that H is equal to what? I square RT, because you're substituting IR in place of V. Simple. We know that I is equal to V by R. So if you substitute the same value of I in the first equation, this equation, what do you get? H is equal to V square by R into T. That's also another formula. So these are the formulas. But if you remember this one formula, remember Ohm's law, that itself is more than enough. Alright. No, I'm from Karnataka, Bangalore. So please explain the effect of an alpha particle moving in a particular direction in uniform. Alpha particles are generally positively charged particles. Right? When you talk about alpha, if I'm not wrong, alpha particles are positively charged, right? All the chemistry pundits, alpha is positive, no? Alpha is positive only, no? I'm right? Tell me, da. Yeah, no. What is magnetic flux? You don't have it, but magnetic flux is nothing but the magnetic field lines per unit area. How many magnetic field lines are moving per unit area or is passing through per unit area? That is magnetic flux. Greater the magnetic force, more number of magnetic field lines will be there, greater the magnetic flux. That's all. Magnetic field per unit area is magnetic flux, but you don't have it. Yes, no? So alpha particle, if they've given you alpha particle, then show whatever, if alpha particle is going from left to right, middle finger, you'll point it in that direction itself. If it's going from right to left, you'll point in the same direction. Alpha, because it's positive, you're going to take the same direction. But when you talk about electrons, since they are negatively charged, you'll take the opposite direction. That's all. Alright. Presentation tip, Dharani, what I would say is first thing, draw margins. Very important, draw margin because it makes it look very clean. Second, do not scribble a lot. Don't scribble a lot. Think about the answer, then write. All right, think about the answer, form the sentence, then try to avoid scribbling as much as possible. I know it's not completely possible to avoid it, but try your best to minimize the scribbling as much as possible. Thirdly, show every step that you do in your numericals. Fourthly, highlight the final answer. Highlight the final answer. Draw a box, draw a circle, whatever it is, highlight in the box would make it look very clean. Try to do that. Then draw diagrams using your pencils. Diagrams that you do, use a pencil for that. All right. And sixth, guys, please try to use ball pens instead of gel pens, because gel pens can get smudged. Don't use ink pen also. Try to use ball pen. If you have, I think black or blue would do, whichever you feel more comfortable, you can use that. I used to prefer black pen a lot. So if you want to use that, you can use it. Blue is also absolutely fine. Whichever you're going to go with that. All right. Yes, try to do so for numericals, is it compulsory to make diagrams? It's not, but I would say please do it, because it helps you clear a lot of confusions. All right, try to do the diagrams. All right, so what will happen if we place a current carrying conductor parallel to a magnetic field? There will be no change, no force on it, because if you remember the formula, what will happen to a magnetic field if on a current carrying conductor, if the magnetic field and current are in the same direction? If that is the case, people, please remember that. If you remember the formula, F is equal to BIL sine theta is the formula. Alright, this is nothing but the formula for Lorentz force, BIL sine theta. So here the angle is 0, theta is 0, so the whole force will be 0. So there will be no force acting on this conductor if a current carrying conductor is placed parallel to the magnetic field. There will be no force at all. Alright, principle of motor is Lorentz force. Lorentz force. The force acting on a current carrying conductor. When a current carrying conductor is placed on a magnetic field, it will experience a force. That is the principle behind it. Alright. Black pen is not allowed. Oh, is it? Then use blue ballpoint pen. Use blue ballpoint pen if that is the case. Alright. But I don't know. For us though, it was allowed. I don't know about you guys. So which is better, sir? Is it tungsten or nichrome in heating element? Because I get confused. See, the heating element, nichrome is what is used. Nichrome is used over tungsten. In filament, we use tungsten. Because again, in heating elements, like for example, a room heater, your intention is not to light up the room. Your intention is to get maximum temperature. So nichrome has higher resistivity, since it's a alloy of nickel and chromium. Because of that, it has higher resistivity. So as a heating element, nichrome is preferred. But when you talk about element inside of the filament, over there, tungsten is preferred. Alright, because of incandescence, because tungsten can produce light at very high temperature. That's why. Alright. How to find direction of magnetic field in what case diandroid? If it's a straight current carrying conductor, you have to use Maxwell's right and thumb rule. If it's a force, if you've kept a conductor in a magnetic field and you want to find the direction, use Fleming's left hand rule. If you want to find out the direction, if the induced current is given, they've given you the force on the conductor as well, then you can use Fleming's right hand rule as well. Depends on what scenario. All right. What is specific resistance? Specific resistance is nothing but resistivity. Resistivity I've already explained. No, it is nothing but the property of the material. Specific resistance is nothing but resistivity. All right. Then don't use it. So why alloys are better than pure metal? Alloy is better because, see, metals in general, right, have certain drawbacks. So when you use an alloy, you can actually cover up the drawbacks or reduce the drawbacks, because you're mixing a metal or you're combining it with a metal which actually has that property that is missing in the pure metal. So alloys in general are much more stronger and have better melting point, higher melting points, because they're a mix of certain metals. It's not just one pure metal, because there are so many different types of atoms in play over there. Okay, that's fine. Okay. So do we need to remember the value of resistivity? No, you don't need to. But remember the basic values, like for copper, it's 1.6 into 10 to the power of 8 ohm meter. So remember that. For silver also, it's around 1.6. So copper, it's 1.64 if I'm not wrong, 64. And for silver, it's around 1.6 into 10 to the power of minus 8 ohm meter. So remember these two, that will be enough. All right. Okay, I am not really sure of that. So people, I am going to stop it here. I don't see any physics doubts anymore, so I'm going to end it over here. I hope this was helpful, guys. I really hope it was helpful. I hope you guys were able to make the best out of it. I think for today, I've been sitting for almost 4 hours in front of the laptop for your exams. All right, and before this also, it's not just today. We've been giving you a lot of sessions in the past, also lots of things we have done in the past. I hope that it was all useful. Honestly speaking, guys, we are also a little we also want to know how your exam turns out to be. It's not just you who are feeling that anxiousness, even we do, because along with you guys we have also grown, along with you guys we have also learned a lot of things, along with you guys we have also tried our best to give you only the best, and you've also done the exact same thing, be it in your exam hall, be it outside also, you've done your very best, and we are hoping that everything turns out to be the best. All the very best of luck, that's all I would say, right? And give your best, stay calm. At the end of the day, you need to be calm, you need to focus, right? It's really important that you stay calm, because you're prepared, you're mentally and physically prepared right now. What you need is to focus, to gather up your courage, to gather up your strength, and tell yourself that it is all right. It's another exam, I can do it, I can do it. A lot of people have done it before me, I can also do it. Just stay calm, right? Stay calm, stay confident, have a smile on that face, that beautiful face of yours. Don't stop smiling no matter what. Give your best, right? And if you feel like, it's getting too much, I'm not able to handle the stress, take a breather, stop for 5 seconds, stop for a minute, take deep breath, calm yourself down, all right? Because when you're calm, your brain can think a lot better when it's rather than when it's under stress. So please calm down and give your best. Jaake foड़ दो, jala do, and fold karao. That's all I can say. All right, good luck, Monika ji. I have tried my best, but yeah, I'll try to solve. So why is steel not used in making electromagnets? Because steel is not a magnetic material. You cannot use non-magnetic material to make electromagnets. You need a magnetic material like iron, nickel. All of these are magnetic material. Steel is not. Steel is not a magnetic material. That's why. All right. You need a magnetic material in order to form, to create or to make electromagnets. All right. Sure. Thank you, Haxji. What is tissue culture? I have no idea. Da. I am not a biology teacher. So which one has more resistance, sir? Alloy or pure metal? Alloy would have more resistance. All right, resistivity of alloys are generally higher, so alloy would have greater resistance. So how solenoid works as a magnet? How solenoid works as a magnet is because when current is flowing through the solenoid, what happens is when current is flowing through the solenoid, there's a magnetic field created. So in a circular current carrying conductor, we know that the magnetic field would be nothing but concentric circles. So here there are several concentric circles which are put together. So all of these concentric circles, the magnetic field of these concentric circles will combine together to form a magnetic field that looks very similar to that of a bar magnet. That's how it works. Simple. Because when current is flowing through a conductor, there is a magnetic field produced. That's how it works. And in the case of a solenoid, it's several turns of these insulated copper wire, which basically forms concentric circles of magnetic field, which combine together to form a magnetic field that looks very similar to that of a bar magnet. All right. Yeah, please don't. Sure, Chitra, tell me what's your doubt. Chaitra, please type out your doubts. So why resistance does not affect the magnitude of current? Resistance does affect the magnitude of current. Now, who told you that, Titan? Resistance does affect. Resistance and current are inversely proportional to each other. Greater the resistance, lesser the current. It does affect. All right. Chaitra, type your doubts and send it. You're asking me to solve your doubt. What doubt? Send me the doubt. No, I can't see through your mind. I'm not Magneto to see what's happening inside your mind. Tell me what your doubt is. All right. Sure. Hi, Prithvi. What's up? How are you doing? Sorry, Parthvi. Yes. What's up? Graph question example. You don't have much graph question. All you have is one graph. That is your VI graph, voltage versus current graph, which would be like this. That's all. All right. To represent Ohm's law. That's all. It's going to be a linear curve. That's all. All right. Sir, मुझे कुछ नहीं आता. I should definitely. No. You will not. You will not. Stay calm. I'm telling you, stay calm. You still have time. Focus now. All right. Past year question papers, go through that. Whoever hasn't started yet, PYQs, solve at least the last 3 to 5 years question papers. All right, go through that. Go through all the concepts that are difficult, that you find confusing. Read the textbook, watch some videos, 5-minute, 2-minute videos. We have put out a lot of videos like that. Go through that. Read your NCRT once. It'll be crystal clear. All the concepts that you feel is difficult, go through that also once. Simple as that. Previous year question papers, go through all the concepts, then try to do at least one mock test paper. We have our own mock test paper that was put up in the morning. Solve that. Go to the description of this video. You'll find a mock test paper link. Solve that mock test. Simple. Go do all of these 3. You will still pass. You will still get through it. All right. But R does not, yes, the R does not depend on voltage versus current, but resistance. See, resistance is not dependent on the voltage or current. Resistance is dependent on the what do you say, on the conductor, because resistance is what, rho into L by it depends on the length of the conductor, area of cross section, and the resistivity of the conductor. That is what resistance depends on. But resistance itself is what? It is nothing but the obstruction offered to the flow of current. So obviously, if the resistance is high, current will be less, because the definition of resistance is obstruction. It is nothing but the obstruction offered to the flow of current. Alright, so circular loop magnetic field lines direction, please explain. Circular loop magnetic field lines are nothing but this. If you have a circular loop, magnetic field lines are nothing but concentric circles. Alright, but as you go towards the center, the loops will become straighter and straighter, and at the center it's going to be a straight line. This is what it looks like. Alright, okay, da. S, it is not BIL S, da, it is BF is equal to BIL S sine theta. BIL sine theta, right? Yes. Sine theta, that's sine theta. Sine theta you already know, no? You have already learned trigonometry, right? So sine theta is that angle between current and magnetic field. So should ammeter, voltmeter connected? I have already explained this several times. So ammeter should be connected in series, voltmeter should be connected in parallel. All right. So what happens to the magnetic field when current in the circuit is reversed? The magnetic field will also change. When the current is reversed, the direction of magnetic field will also change. All right. So how resistor dissipates heat? It dissipates heat through the wire. The wire becomes hot, right? That is how it is. The entire surface of the area, the surface area of the of the wire gets hot. It'll start to dissipate heat to the air around it. That's all. Hi Lakshmi, vanakkam. All right. So I think thank you. That's all. Anything else, sir? Chaitra, send it just like how you are sending. I'm typing my doubt and not seeing it. Send the same way your doubt also. I'll clearly see it. No, send it now. I'll not be able to see the chats before that. No difference between kilowatt and kilowatt hour. Kilowatt is the unit of power. Kilowatt is the unit for power. Kilowatt hour is the commercial unit of energy. Commercial unit of energy. It is the commercial unit of energy. SI unit of energy is joules. SI unit of power is watts. The higher unit of watt is kilowatt. The commercial unit of energy, on the other hand, is not joules, it's kilowatt hour. Why? Because joules would give you a huge value. In order to make it a little bit more easier for us to read, for us common people to read, that's why it is given as kilowatt hour. All right. All right. Anything else, sir? Is there? Yeah, you can take it as QEB sin theta also. That you'll study in your higher grades. Don't worry. All right. QEB sin theta, BIL sin theta is basically the same thing itself. Certain difference. That's all. It's basically the same thing. All right. But you'll learn that in the higher grades. You'll learn it in your 11th and 12th. All right. So magnetic field due to current carrying circular coil held vertically in north south, and observer is looking from east. A magnetic field due to current carrying conductor vertically in north south direction. All right. The observer is looking from the east side. So from the east, he's saying the direction of flow in anti-clockwise. So okay, it's a circular loop. Oh, all right. It's a circular loop. The magnetic field due to current carrying coil held vertically in north south direction. The observer is looking from the east. Current is flowing in anti-clockwise direction. So if current is flowing in this direction, what is the direction of the magnetic field? What is the question? The direction of magnetic field in this direction. Current is going in the upward direction over here. It will be basically in this direction. It's going to be in anti-clockwise direction. Magnetic field also will be in anti-clockwise direction because current is going in the upward direction. So it will be in the anti-clockwise direction. All right. So it's going to be like this. All right, it's going to be like this. On this side, on the other hand, current is going in the downward direction. So if you look at the magnetic field, it's going to be like this. All right, so that's how you find it out. So when you see from the east also, it will look like this. All right. All right, any other doubts? Why change in magnetic field induces an EMF? Because there's a force that is experienced by the electrons that are there inside the conductor. Those electrons will start to move because of the potential difference induced. The electrons will experience a force. There's a potential difference induced or a voltage is induced, because of which the electrons will experience a force and they'll start to move. That is why current is produced. All right. Will derivation be asked in exams? There are not many derivations, smaller derivations you have, small things. That though, please go through it. Few things, no, like for example, Joule's law of heating. How do we get that? Energy, electrical energy. How do we calculate that? So all of that work done, all of that, calculate that. The smaller derivation. So yeah, you need to remember it. They might ask it as a 2-mark question or a 3-mark question. All right. Magnetic field due to current carrying solar. I've already explained that. Any other doubts? Sure, no worries. Okay. Yes, Ananya, only physics. Sorry, da. Only physics. So, when you solve only the... Yeah, da, only physics. Sorry. So, can you please say the general formula of all functional groups? Sorry. Lenz's law. Okay, you don't have all that. Da. Just let it go. All right. Just let it go. All right. Okay, so people, I'll end it now. That's enough. I've already spent more than 2 hours now. Take care, people. All the very best of luck. Let me know how your exam goes. Tomorrow we'll be solving the entire answer sheet also. So be there to cross-check your answers, see if you've given the right answer or not. Tomorrow we'll be coming live. All 3 of us, Pritesh sir, Shilpi ma'am and me will be coming live tomorrow. We have to decide the time, no? It will be around 1 or 2 o'clock to solve your answer sheets, to see how well you have done, how much you have answered, whether it's right or wrong. All of that we'll be checking out tomorrow. So until then, adios. All the best of luck. Perform well. 4 ke aana. All right. Jala ke aana. Again, burn the whole school down once you get it done. So that's all I would say. That's all for today. Take care of yourselves. Bye for now. Enjoy yourself and have a smile on that face. Good luck. All right. And every time it gets difficult, take a breather. All right. Take a break, breathe, calm yourselves down. All right. So see you soon, people. Enjoy yourself and perform well. All right. Don't leave anything till tomorrow morning. Finish whatever you have to tonight itself, whatever it is, whatever revision, whatever you have to do, whatever concepts you need to learn today itself, you need to finish it today, right before you go to sleep. Finish it off, because don't leave anything in the morning, because it'll be all hodgepodge in the morning. Finish it off today itself. That's it. All right. Okay then. Bye guys. See you all. Take care. I'm so sorry, Chaitra. I tried to, but yeah, take care. Bye guys. See you all. All the best. Good luck. Do well. Proud of you.